Dear students, hello everyone. I'm here again with Kimana, a geography and social studies tutor from TTC Zansa. I would like to invite everyone to today's lesson related to Earth movement. I wish you to enjoy today's lesson as we enjoyed the previous ones. So, welcome.
Angle of 23.5 degrees. The Earth rotates around its axis once a day. The tilt of the axis affects when seasons occur. When the axis tilts toward the sun, the northern hemisphere experiences summer, while the southern hemisphere experiences winter. In half a year, the Earth
Dear student teachers, as I told you, I'm here again with Kimana, geography and social studies tutor from TTC Zaza. Now, I'm going to share with you a geography lesson related to Earth movement. This lesson is designed for TTC students from three options. One, social studies education option. This lesson is linked to Unity 4 in Geography in Year 2. It is linked also to Unity 3 of Social Studies in SME and LE option. The lesson of today is linked to Year 1 SLP student teachers in the subject of Social Studies in Unity 2. The objectives of today's lesson is this. In this lesson, the student should be able to describe Earth movement and their effects. Now, let's start with Earth movement. Here, there is an activity designed for you, dear student teachers. The activity 1 is saying like this. Read the following paragraph and answer the questions that follow. The paragraph is this. Let us read it together, dear student, where you are. Imagine a line passing through the center of the Earth that goes through both the North Pole and South Pole. This imaginary line is called an axis. The Earth spins around its axis. This spinning movement is called the Earth's rotation. At the same time, the Earth spins on its axis. It also orbits or revolves around the Sun. This movement is called the revolution. Dear student, after reading this paragraph, now answer to this question. Identify the Earth movements described in the above paragraph. Second, let us answer together the question as we read together the paragraph above. As the Earth moves, it makes two movements at once. These movements are Earth's rotation and Earth revolution. During this lesson, we are going to examine these two movements of the Earth. We will explore also their effects. Let's start with rotation of the Earth. Dear students, observe this image. It will help us to understand the rotation of the Earth. Dear students, observe this image above, and I'm going to show you a short movie. After observing the short movie with this image on the screen, you will explain the meaning of Earth's rotation and its effects. Now, let me show you the short movie which will help you to explain what is Earth's rotation. Now, it's up to you to follow this movie and explain Earth's rotation.
The Earth's axis of rotation, or the wobble effect. Let's begin by talking about the Earth's axis. The Earth rotates on an axis. The axis is tilted at an angle of 23.5 degrees. The Earth rotates around its axis once a day. The tilt of the axis affects when seasons occur. When the axis tilts toward the sun, the northern hemisphere experiences summer.
Now I think you have observed where the movie. Let me play it again.
On an axis. The axis is tilted at an angle of 23.5 degrees. The Earth rotates around its axis once a day. The tilt of the axis affects when seasons occur.
Now, dear students, it's up to you to answer to the asked question. The asked question is saying, explain the meaning of Earth's rotation and its effects. Can you explain the Earth's rotation? Rotation of the Earth. What is Earth's rotation? Rotation of the Earth is the movement of the Earth around its axis. This movement is completed in a period of 24 hours. Within 24 hours, I mean day and night, the Earth completes a tour of 360 degrees, which equals to 1 day. Now, while moving, the Earth moves very fast at the speed of 1,676 kilometers per hour. Rotation of the Earth is made in a direction of anti-clockwise direction. I think, as you saw on the movie, the Earth moves in an anti-clockwise direction. Look at on this image, you see the direction of the Earth. It moves like this in a direction of opposite of the hands of the clock. Let's proceed with its effects on the environment here on the Earth's surface. The Earth rotates on its axis in 24 hours, as you have seen above, and this causes various effects on the environment. One effect is this: rotation causes day and night. You have day and night on the Earth due to Earth's rotation. Rotation causes also tides. Do you know tides? We are going to explain later on tides. Deflection of winds and ocean currents. Rotation also causes a time difference between longitudes. Lastly, rotation causes a temperature difference here on the Earth. Dear students, let's start with rotation and how it causes day and night on the Earth. Observe this image clearly and you will understand well how Earth's rotation manages day and night here on the Earth's surface. As you see on this diagram, here we have sun rays and the part exposed to sun rays, it experiences daytime. This part here, it is in daytime, while the part of the Earth which is located in opposite side of sun's rays will experience night time. This is how the Earth causes day and night here on the Earth's surface. Now, let's proceed with the second effect. Rotation causes tides. Tides means the rising and falling of ocean water. There is a time when ocean water rises its level and when the ocean water decreases its surface level. This is what is called the tides. When the earth is exposed to sun and the moon, the ocean level will increase because these tides are influenced by the gravitational forces of the sun and the moon. This is how the part of the earth exposed to sun and the moon, the waters located there will rise the level or will increase in terms of level, while when ocean water is not exposed to sun and moon, the level will decrease. The third effect is deflection of winds and ocean current. This phenomenon is called the Coriolis effect. Rotation causes wind to be deflected to the right in the northern hemisphere or to the left in the southern hemisphere of the earth whenever they cross the equator. This deflection of winds is called the Coriolis effect. Let us have an example here in our everyday life. You observe this image, a man who is riding a bicycle. Consider a person riding a bicycle. You see his clothes. His clothes are swayed behind him. You can ask why. This is because wind is blowing in an opposite direction compared to the direction of the bicycle. This is what happens on winds when they crosses the equator. As the earth moves from west to east, winds will move from west to east in opposite direction. This is deflection of winds. The fourth effect is temperature difference on the earth's surface. Dear students, as you know, we experience different temperature in different regions. This is because of Earth's rotation. Due to the spherical shape of the Earth, the parts of the Earth located in the tropical areas between 23.5 degrees north and south of the equator, they get direct sunlight all the year around. Regions near equator or regions between tropics, I mean the Tropic of Cancer and the Tropic of Capricorn, they experience direct sunlight throughout the whole year. Regions located in higher latitudes get less rays during the year. I mean regions near southern pole and regions near northern pole, they experience less sun rays during the year. This is because of Earth's rotation. The last effect, it is time difference between longitude lines. Do you know a longitude lines? Longitudes are those vertical imaginary lines drawn on Earth's globe. These lines help us to control time on the Earth. One round of the Earth rotation is completed within 360 degrees. This equals to 24 hours. Therefore, for the Earth to cover 1 hour, it is calculated by dividing 360 degrees divided by 24 hours, which will give us 15 degrees. If it takes the Earth to cover 15 degrees in 16 minutes, then 1 degree is completed within only 4 minutes. This is obtained by dividing 16 minutes by 15 degrees. After 4 minutes, the Earth moves a distance of 1 degree. Now, let us look how you can calculate local time using longitude lines. Let us have this example. If the local time at the Greenwich media is noon, 12 o'clock, what is the local time at Kigali, which is located at 30 degrees east? Yes, student, Kigali is located at 30 degrees east in terms of longitude. Then, if it is 12 o'clock at Greenwich media, remember, is located at 0 degrees. What will be the time at Kigali? How will we proceed? First of all, find the difference in degrees between two latitudes. Difference between 30 degrees east and 0. We will take 30 degrees minus 0 and we will obtain 30 degrees. This is the difference. Second, multiply this difference by 4. Remember, 4 minutes correspond to 1 degree. Now, this will be 30 degrees times 4 minutes and we will obtain 120 minutes, which correspond to 2 hours. Therefore, since Kigali is located in east of Greenwich media, the time at Kigali is 2 hours ahead Greenwich media. Remember, in the example they said at Greenwich media we have 12 o'clock and Kigali is located in east of Greenwich media. Now Kigali is at 2 hours ahead compared to Greenwich media. This is the reason why Kigali's time is 2 p.m. 2 p.m. I think it is understandable. Now, let's proceed by examining how to determine the longitude of a place using the local time. An example is this one. Given the local time at the place 1 is 10 a.m. and the local time at Greenwich is 12 o'clock. What is the longitude of place 1? Can you guess the longitude of place 1? Let us now proceed. First of all, you will find the difference in time between the two longitudes. The difference in time equals 212 minus 10 and we obtain 2 hours. The Earth rotates through 15 degrees every hour. Therefore, in 2 hours, it will rotate 30 degrees. The time at longitude 1 is behind that at Greenwich media. This is the reason why Y is located at 30 degrees west. When I say west, it is west of Greenwich media. This is how you calculate, how you determine longitude of a place using the local time. Let us now take a short break. Let us take a short break before progressing to something else. Before moving to something else, let us have a short break by listening and watching this song. It will help us to have a short break.
Thank you.
you enjoyed the break, let us progress with our lesson with the next movement of the earth, which is revolution of the earth. As we have seen, the earth makes two movements, rotation and revolution. Number 2, let us describe earth's revolution. Observe this image and continue with activity 3. Observe the above image. I'm going to show you a part of the movie. Then the activity is this. After watching the following movie and observing this image here, explain the phenomena that is taking place there. Describe the effects of the above phenomena in Earth. Describe the phenomena that is taking place in this image. I'm going to show you also a movie. Then, what are the effects of this phenomena that is taking place there in the image and this movie that I'm going to show you. Wait.
The Earth's axis of rotation.
Now I want
So the Earth's axis has only complete a full cycle, approximately every 26,000 years.
What is the phenomena that is
Today,
taking place?
this is how the seasons correlate with the axis of rotation and its orbit around the Sun.
Observe what is taking place in this movie.
3,000 years ago, the axis of rotation and the season.
Thank you. Now, let us proceed with our lesson. What is being represented in the movie and in this image? I think you have discovered that it is Earth's revolution. Now let us examine the meaning of the revolution. The revolution movement is Earth's movement around the Sun. As you have seen on the image, in the movie, Earth was moving around the Sun. The Earth takes 365 days and 6 hours to complete one revolution. This has important effect to environment. The Earth, to complete one tour around the Sun, it takes the whole year. And while moving on the environment, we will experience the effects of this Earth's revolution. The first effect, it is changes in seasons, varying length of day and night, the beginning and end of the year, and lastly, changes in altitude of the midday sun. 1. Changes in seasons. Different parts of the earth experience climatic changes due to changing position of the earth around the sun. And on the earth, we have 4 seasons because of Earth's revolution around the sun. The first season is summer. Do you know summer? Summer is the hottest season among the 4 seasons of experienced on the earth throughout the year. It occurs between spring and autumn. It is characterized by high temperature on the earth. Let us continue with the second season, spring. Spring is one of the 4 seasons, and it is located between winter and summer. 3. Autumn. This is the 3rd season, located between summer and winter. The last season is winter, which is located between autumn and summer. These are 4 seasons we have on the earth during each year because of because of Earth's revolution around the sun. Winter and summer are hot seasons. Spring and autumn are wet seasons. Now, let us proceed with another effect: varying length of day and night. Day and night are not always equal. There is days where we have long night and short daytime, and in other time we have long day and short night time. But in other time we have day and night that are equal. Observe this diagram, it will help us to understand this later on. Now, the sun is vertically overhead at noon over the equator on 2 days each year. This is on 21st March, where we have spring equinox, and on 23rd September, where we have autumn equinox. On these 2 days, all parts of the earth have equal hours at day and at night time. This time of the year is called the equinox. Equinox means equal length of day and night. So we have 2 equinoxes throughout the year: spring equinox on 21st March and autumn equinox on 23rd September. On the other hand, when the sun is vertically overhead at noon over the Tropic of Cancer on 21st June, in this period we will experience summer solstice, and on 21st September also, here we will have winter solstice. On 21st September, the sun will be over the Tropic of Capricorn. On these 2 days of each year, day and night are not equal in both hemispheres. The third effect is the beginning and the end of the year. Year start or end because of Earth's revolution. When the Earth completes one revolution, it is referred to 1 year, and when our year ends, we start the second year, and so on. And for instance, if you have 20 years, or if you are 20 years old, it means from your birth, the Earth has completed 20 tours around the sun, or it has completed 20 revolutions around the sun. So, to count years depends to the number of tours the Earth may be around the sun. The fourth and the last effect of Earth's revolution, it is changes in altitude of the midday sun. Earth's revolution exposes different parts of the Earth to the overhead sun differently because of the inclination of the Earth axis. For instance, parts of the Earth beyond the tropics never experience the overhead sun, while the equator and the tropics experience the overhead sun alternatively during equinoxes and solstices. My dear students, there's a part of the Earth located, for instance, on northern pole, on southern pole, they never experience the overhead sun. And When the overhead sun at noon is located on equator, you will look in atmosphere and you will observe the sun located in the center of the sky. When the overhead sun is located in southern hemisphere, for instance, people located in north will observe the overhead sun in south. The overhead sun will not be above them, it is in another side. This is how Earth's revolution contributed to changes in altitude of the midday sun. Let us now continue with activity 4. This is sentences. The activity 4 is going to help us to summarize what we have seen throughout this lesson. Dear students, teachers, watch the following movie and make the summary of what we have studied today. You are going to watch this movie and summarize, make the summary of what you have seen today. Now it's up to you to observe and watch, listen carefully and write down the summary of today's lesson. Welcome to this.
The Earth's axis of rotation, or the wobble effect. Let's begin by talking about the Earth's axis. The Earth rotates on an axis. The axis is tilted at an angle of 23.5 degrees. The Earth rotates around its axis once a day. The tilt of the axis affects when seasons occur. When the axis tilts toward the sun, the northern hemisphere experiences summer, while the southern hemisphere experiences winter. In half a year, the Earth will revolve elliptically, counterclockwise around the sun, while the axis stays tilted at 23.5 degrees. When the axis tilts away from the sun, the northern hemisphere then experiences winter, and the southern hemisphere experiences summer. The axis of rotation, also known as the wobble effect. The Earth's axis has an axis of rotation, and, just like a top, the axis spins. The angle does not change, only the direction of the axis. The axis of rotation will complete a full cycle approximately every 26,000 years. Today, this is how the seasons correlate with the axis of rotation and its orbit around the sun. "3,000 years ago, the axis of rotation and the seasons would have looked like this. "3,000 years from today, the axis of rotation will have moved more than 1/9 of a full cycle. Therefore, in 13,000 years, the occurrence of the seasons will be opposite than it is from this year. After 26,000 years, the axis of rotation will have completed a full cycle, and the occurrence of the seasons in the Earth's orbit will start over. In relation to the stars, the Earth's axis currently points toward the star Polaris. Due to the axis of rotation, the Earth's axis will be pointing somewhere near the star Vega in 13,000 years.
Yeah, thank you for watching the movie. Now, I think you have completed writing down the effects of Earth's rotation, the effects of Earth's revolution, what is revolution and what is rotation, as you have seen them throughout this lesson. Now, let's proceed with assessment. Take your pen and answer today's questions. Question 1. Rusizi is located at 28 degrees east and the time is 6 a.m. What is the time in place which is located at 60 degrees west? Question 2. What is the longitude of place X whose local time is 11 a.m. if the local time at longitude 30 east is 2 p.m.? The third question. Discuss why areas in Arctic cycle are always cold and covered by ice. Please answer clearly to these questions according to what you have discussed throughout this lesson. Enjoy the test. While answering to this question, let me give you a short break for answering these questions. You have a short break while listening to this song. Thank you very much for your hard work. I think you have finished everything about the assessment. Now, the assessment was this one. The last is to tell you thank you for your attention today. See you next time throughout the next session. And as you have enjoyed the lesson, please to continue to obtain other lessons, make subscription to this one, and I wish you good time, I wish you good moment. Stay safe, stay at home. We'll meet for next time during the next lesson that I'm preparing for you. Thank you very much for today.